Okay, we will have next talk of our evening part of program Quantum Research and Education in Kyiv Academic University, Alexander Kordyuk, academician and rector of this university.
Okay. Thank you very much for introduction. I will briefly go through Kyiv Academic University and let's say educational part and research part. So I want to briefly include all this our activity. Because actually Kyiv Academic University, it is the main idea about Kyiv Academic University that we do this learning by doing research. And we add internationally because, of course, now science always international, research is always international. But in case of Ukraine, it is vitally important because many experimental technique are not accessible in Ukraine, but with international collaboration, we have the success, of course. I'm a director of service director of Kyiv Academic University, and also I'm head of department of Institute of Metal Physics. So I combine these ideas of research and education. And Kyiv Academic University is rather small in terms of students. We have you can see it is our number of students almost like this. And of course, here is just several graduation days. It is just from last 2 years, and these are not all people due to problems with COVID, and also due to the fact that many our people are actually in abroad, passing scholarships, making scholarships. But we have approximately about 30 students per year, and this amount is for physics, for math, and for biology, for math, cybernetics, and biology. And it is, I would say that for physics, it's about 10 per year. And for these students to teach to the students, we have about 40 professors. So for professors, amount of professors are larger in our case, but it is not a problem. We like it, we like the situation, because our lecturers, they are all part-time lecturers, because they are researchers, and only part-time, very limited time they spend for teaching. And this is I actually from my when I was student, I remember how it is important to have people who can teach you, but who are real researchers. And this contact is very important, and we force as much as possible the central discipline, I would say, in our university is just research, and all the lecture courses are around it. And actually, briefly to say that we have several departments. Now it is 7 active departments. I say it's not only physics, but these departments they are located at different academic institutes. And I should say that Kyiv Academic University, our aim is not just to have our students, to teach our students, but our aim is to involve students, to involve young people to research. And we are like a bridge between academy, between other universities and academy. We always open for all other students, and in all our projects and collaborations in international projects, they are all open for also students from other universities. And here you see these guys. It is they just represent. This is a recent photograph, which are in Physics Today now, and some other journals. it is just our collaboration with IFW Dresden about quantum material, if to say it briefly, materials. And this is just continuation of one of our projects, which I will tell a bit. And Kyiv Academic University, we have this name academic because we are actually, it is the only university in our academy. Therefore, we suggest to our students and to all other students who go to us just for research, not for study, we can suggest the best groups in academia. Okay, so a few words about quantum education. We do not have actually formal program about quantum technology, as for example in Lviv University or in physical department in Kyiv National University. But we have a number of courses, and we keep it free for students to collect these courses. So we keep possibility, we support possibility to choose courses between different departments. And here you actually the main contributor to the quantum courses from theoretical department is Andrei Semyonov. You saw his talk. And we have several other courses there. Of course, they may be even more difficult for people. And in our department it is located to Institute of Metal Physics. It is called Applied Physics and Nanomaterials. We have more direction to material research and quantum materials. And in Department of Mathematics, I should mention the introduction to quantum computing. So of course, we had Danila Yakimenko. Okay, but we also support other activities, and we realized quite long ago that it is that education, it is the thing which we could do easier than research, of course. And from one side, from one hand, on the other hand, the education should go side by side with research. Therefore, to provide good education, we need, of course, to develop our own research. And therefore, we have now idea to develop not only departments at academic institutes, but also research in Kyiv Academic University. And we have already a few laboratories which are focusing on quantum technology, let's say. And I should say that we had a few schools, and actually we have a regular quantum seminar. And actually here you can just by these links you can see how it is. And as I said, we consider that international collaboration is a key component of our university and our research also. And I would address three important projects. I would say it's UKRATOP, which is now evolved into UKRAPRO. And we have, it is just continuation. We are now working on within the project. This is German project, BMBF project. They should support the Center of Excellence, and now is preparational phase. And I also could will mention the NATO Science for Peace project, but it is the topic of the next talk by Vladimir Shnerkov. So UKRATOP, it is focused on topological quantum materials. It is fundamental, it's not applied, but it is just continuation of our good collaboration with IFW Dresden and with TU Dresden. So, and DU, it is, that was about 1 million euro for 4 years, and especially important, especially good for us, fits the best to our program is just a scholarship for master students. It is 21 master students, not only from Kyiv Academic University, as I told, from other universities who pass this program, and it is 6 months, but it is very good experience, and I'm very happy. I was very happy to observe how it is good for our students, how they increase their experience in everything. Okay, I probably skip this for the time. I just should say that we realize importance of this danger of the brain drain, and we are constantly thinking and discussing how to convert it into brain circulation, and it's just one recipe which we understand. It is just direct links, scientific links between the groups, and then you inevitably have a backflow. I have mentioned already, I will say the most quantum of our project. It is just creation of single microwave photon counter based on tunable flux qubit, but I leave it for Vladimir Shnerkov. Just should say that here is just shows the collaboration in which we involved. It is with Pascal Fabre from University of Savoy Mont Blanc and Sergei Shevchenko. It is from Kharkov. You saw just him. Miroslav Greitzer, we have mentioned him from Cornelius University and from Bratislava, and Vladimir Krasnov from Stockholm University. Just to mention quantum startup, because we also have some projects. We are here, especially it was activity, of course, before the war. Now it is stopped. It is for creation of here academic park and scientific park, and it will call it Academ City, and also the German scientists or German experts involved here, who built the Berlin Adlershof Park sometime. But actually, I go now to research topics, and only one research topic I will highlight, which more my research topic, I would say. I mentioned already that we develop this laboratories, the scientific part, the research part in university, and we have 2 laboratories which deal with superconducting quantum electronics. And also in collaboration, of course, with Department of Superconductivity and Institute of Metal Physics, where we have helium station and so on, but we are still far from micro Kelvin, of course, but we still have helium temperatures, but we hope we will do it sooner or later. And the topic with which I want to finish, it is just relation of relation of electronic structure of materials, of topology of, for example, superconducting condensate, to how one can relate, how one can use this knowledge to build a better superconducting devices. So a few words about my experience in HITC. I told already several times that it is my method is angular resolve photoemission spectroscopy, but this means that it is probing of electronic structure, and with this method we can know everything about electronic structure, and having a long experience with this, I'm sure that actually electronic band structure is the main important thing which define all the properties, and of course especially such properties as for electronic properties. And for example, when people say about Hubbard model or something like this, it is just, let's say, or sometimes it could be considered as another language, but sometimes it could be considered as really something missing. And we actually understood the importance of band structure in cuprates, and that actually it is band structure which gives you excitations, magnetic excitation, spin excitation, which couple the pairs. And then we realize the importance of electronic structure for superconductivity in iron-based superconductor. This means now I would say that this relation is empirical, but we always see that it is important that we have small Fermi surfaces, and it is called proximity to Lifshitz transition, and it seems it boosts superconductivity, and it seems that the same situation is also in cuprates, but also now I would switch to importance of the Fermi surfaces, electronic structure, to understand the properties of Josephson junctions. And a bit about motivation. It is just now state of the art of superconducting qubits, it's aluminum technology. And of course, I understand that just all other Josephson junctions are far away in gate fidelity. Yeah? But they have also the problem. It is low energy of communication, and because of this is the coherence. And it is anyway interesting to explore the possibility to increase the frequency, to increase the Rabi frequency of these elements. And the evident way is just to use superconductors with larger superconducting gap. And to characterize it in Josephson junction, it is ICRN. It is ICRN property. It is critical current multiplied by normal resistance. It is just proportional in simple compounds, proportional to superconducting gap. And if you see aluminum superconducting gap, it is 0.3 millielectron volts. And for example, if you compare it to cuprates, it is 20 millielectron volts. So it is almost 2 orders of magnitude higher, and we can increase frequency. But of course, these compounds first, they're difficult to realize the Josephson junction. It is first thing. And second thing, we have superconducting order parameter is changing sign. And it is interesting fundamental problem, but it usually does not help you to make good Josephson junction. And for example, okay, I will skip it. For iron-based superconductors, in iron-based superconductors, it is also the fundamental problem to understand and to find out which actually symmetry of this system. Angle resolve photoemission spectroscopy, it is not phase sensitive, so we can't say the sign of the order parameter. And for this, we should one of the way, of course, evident way to use the transport and to use the Josephson junction technique. And we were sometimes inspired with this work, in the sense that I didn't believe in this result, that they show that it is really S plus minus symmetry of superconducting order parameter. And the idea was just to make a Josephson junction and to show that it is not the case. But to make a Josephson junction between iron-based superconductor and just normal niobium, it from Alexei Kordyuk from our department, it took about 3 years in Krasnov laboratory to develop the methodology and to obtain really such interference pattern to get good enough Josephson junctions. And it was first in the world, this result, the realization of Josephson junction on iron-based superconductors, but actually, the result was unexpectedly opposite for me, because it was shown that ICRN is extremely low. Extremely low, this means that we have like destructive interference. We have transitions to plus and to minus superconducting order parameter, and therefore they almost cancel each other, and therefore it's good fundamental result, but it's not applicable for Josephson junction, for qubit, for example, to build qubits. But it's recently Alexei did very interesting observation. He incorporated the copper layer in between niobium and iron-based superconductor, and he expected to get better quality, but worse characteristic. But it was another way around. JCRN is increased 40 times, as far as I remember about. You see now it is experimental picture. They look like simulation. It is really high quality system, but we should understand it how. The idea it is on the surface that the Fermi surface is on the Fermi surface. The Fermi surface is very important because we have direct transition between layers, and we have effective Fermi surface from the polycrystalline gold, and we have Fermi surface real because it is single crystal of iron-based superconductors, and therefore this Fermi surfaces looks like a filter just to allow the transitions to one sign of the superconducting order parameters. And because of this, it shows which the correct showed us the correct symmetry of the superconducting order parameters. And second, it is, I think, very interesting way for intelligent design using the Fermi surface to design what you want to adjust in parameters of the superconducting elements. Okay, so I think that's it. Thank you for your attention. It is just a real experimental electronic structure, but it is for excitonic insulator. But nevertheless, I usually show it to say that, to emphasize that really, I believe that electronic structure is really important. Thank you.
Thank you for interesting talk. And do you have questions? Question in the chat.
Okay, so, that was not the question. That was that Andrei didn't see my presentation.
Andrei, did you see presentation?
Have you seen presentation finally? Probably not. Okay.
Okay, then I have some questions, some global question. What do you see some optimistic perspectives for academic university in real situations now and after war?
Yeah, of course. Now it is it is hard question as you understand, because it's no one can say what to expect in nearest months, or actually in even in nearest year. I was sure that this war will not so long, because I expected that we win much faster, but with foreign help. But actually, it seems it's not the case. And it's clear for me that it will be tough time for science, for Ukrainian science. But especially for it, it is important to develop international collaboration. And I hope that, and I'm sure that we will go in this way, that international collaboration, it is our actually point or our advantage, that we anyway we plan to put much weight on international collaboration, and now it is doubly so.
Mm-hmm. Okay, and what situation now with new students? Because
you know that this year it is shifted the session, so everything is shifted in 1 month. Therefore, we will have admission process will only start in half a month, and it should finish in September. Not so. And I think as always, it will be not a lot of students which we will have, but it's okay for us. We need only the best students who are interested in real research.
Okay, and I hope that this time and our institute will have also students.
Yeah, it is also. I also hope so.
Okay, so thanks again for the interesting talk. And now we, as I understand, we have